Introduction. In the early morning of February 15th, 2013, over the southern Ural Mountains of Russia, the sky lit up with a blinding flash. A brilliant bolide, later named the Chelyabinsk meteor, entered the Earth's atmosphere and exploded high above the city of Chelyabinsk. Fragments of the space rock rained down across the region, one of which punched a hole through the ice of Lake Chabarkal. This was one of the most dramatic meteor events in modern history. What followed was an extraordinary recovery mission. Scientists and divers retrieved the largest fragment from the lake's muddy bottom. The story sparked global fascination, inspired new scientific studies, and renewed international discussions about planetary defense against asteroids. Below is a detailed account, from the first explosion to the recovery operation, the fragment's current location, and how the world viewed the event both in 2013 and today. The impact and immediate aftermath. The explosion in the sky. At around 9:20 a.m. local time, UTC+6, on February 15th, 2013, a space object roughly 20 meters in diameter and traveling at about 19 kilometers per second entered the Earth's atmosphere. It created a blinding flash, brighter than the sun, and an enormous shockwave that shattered windows and damaged buildings. Thousands of people across the Chelyabinsk region witnessed it. Dashcams and security cameras captured the meteor's fiery descent, making it one of the most documented natural events in history. The shockwave injured approximately 1,500 people, mostly from flying glass. Scientists later determined that the object exploded at an altitude of 25 to 30 kilometers, releasing energy equivalent to 400 to 500 kilotons of TNT, dozens of times more powerful than the Hiroshima bomb. The strewn field and the hole in the ice. Fragments of the meteor scattered over a large area, what scientists call a strewn field. One fragment struck Lake Chabarkal, leaving a 6 to 8 meter wide hole in the frozen surface. Local residents soon found small black stones in the snow nearby, which turned out to be pieces of a meteorite. These first discoveries confirmed that a major meteorite fall had occurred. Scientists and emergency services quickly mobilized to collect samples, map the impact area, and locate the largest fragment that had fallen into the lake. The search for the largest fragment. Early investigations. Within days, divers and scientists began probing the lake. Magnetic surveys, seismic readings, and sonar imaging detected disturbances in the sediment, suggesting that a large mass lay buried beneath several meters of silt. By March 2013, divers had already recovered a few kilograms of small fragments using magnets. Researchers estimated that a much larger body, possibly weighing between 200 and 800 kilograms, rested deeper below. The recovery mission. In September 2013, a large-scale underwater operation began. Engineers and rescue divers worked with heavy lifting equipment, dredging pumps, and underwater cameras. They removed over 100 cubic meters of mud and silt to reach the buried object. Finally, on October 16th, 2013, the team succeeded. They pulled a massive meteorite fragment, weighing roughly 540 to 570 kilograms from the bottom of Lake Chabarkal. It immediately became one of the 10 largest meteorite pieces ever recovered on Earth. During the lifting process, the rock cracked into several pieces and even broke the weighing scales used on the barge, a detail widely reported by Time and other outlets. In total, 8 major fragments were recovered from the lake, weighing together about 640 kilograms. The meteorite's scientific and museum life. Classification and study. Scientists classified the Chelyabinsk meteorite as an ordinary chondrite of type LL5, with a shock stage of S4 and weathering grade W0, meaning the samples were remarkably fresh. The fragments have since provided unique insights into the composition, history, and metamorphism of small solar system bodies. They show evidence of multiple collisions and heating episodes over billions of years before the rock finally reached Earth. The largest fragments home. The largest recovered piece, lifted on October 16, 2013, is now displayed in the State History Museum of the Southern Urals in Chelyabinsk. Visitors can see the massive stone, dark, cracked, and bearing fusion crust from its fiery descent. Smaller fragments are held in museums and research institutions across Russia and abroad, including exhibitions in Europe and North America. The world's reaction in 2013. When the meteor exploded, the world's media erupted with coverage. It was the most powerful atmospheric explosion recorded since the 1908 Tunguska event. Time magazine described the recovered fragment as one of the world's biggest meteorite pieces ever pulled from a lake. Scientists emphasized how the event caught everyone by surprise. The meteor came from the direction of the rising sun, making it invisible to telescopes and radar. Videos of the blinding flash and shockwave went viral within hours, highlighting both the fascination and the vulnerability of modern civilization to cosmic impacts. Early analyses estimated the energy of the blast at several hundred kilotons, sparking debates about how humanity could defend itself from similar future events. How the event is seen today. Lessons for science and planetary defense. Over the past decade, the Chelyabinsk event has become a turning point in understanding near-Earth objects, NEOs. It revealed that even relatively small asteroids, around 20 meters across, can cause widespread damage if they explode over a populated area. The incident led to new international programs for asteroid detection and monitoring, development of early warning systems for bolides approaching Earth, renewed focus on planetary defense missions, such as NASA's DART test in 2022. Scientific studies have also traced the meteorite's pre-impact orbit, possibly linking it to asteroid 2011 EO40. Researchers refined models of how shock waves propagate from airbursts and how atmospheric entry breaks up stony asteroids. Modern understanding. Later analyses adjusted earlier estimates of the explosion's energy and size, showing that initial media numbers were often exaggerated. Scientists now understand that typical meteor airbursts behave differently from nuclear or chemical explosions. Their energy is distributed over several kilometers of altitude, producing unique atmospheric effects. Today, the Chelyabinsk meteor remains a benchmark case for calibrating models of asteroid entry and damage prediction. Chronology of key events. 1. February 15, 2013, bright bolide enters the atmosphere, explodes over Chelyabinsk, and creates a shock wave that damages thousands of buildings. 2. Same day, a hole 6 to 8 meters wide is found in the ice of Lake Chelyabinsk, believed to mark the impact of a major fragment. 3. Spring 2013. Locals and scientists collect small meteorite pieces from the snow. 4. Summer 2013. Magnetic and seismic surveys of the lake bed confirm a large buried object. 5. September. October 2013. Diving and recovery operations culminate on October 16th with a successful lift of the largest fragment, 570 kg. 6. Late 2013 onward, the recovered meteorite becomes a museum exhibit. Scientific studies begin worldwide. 7. Following years, dozens of research papers analyze its chemistry, mineralogy, and orbital origin. The event inspires new asteroid detection programs globally. Why it matters. The Chelyabinsk meteor taught scientists and the public several important lessons. Even a small asteroid, only tens of meters wide, can produce an explosion equivalent to hundreds of kilotons of TNT. Earth's current detection systems were blind to objects approaching from the sun's direction. The event demonstrated the need for global cooperation on asteroid monitoring and impact response planning. It also provided a treasure trove of scientific data, thousands of eyewitness videos, atmospheric measurements, and fresh meteorite samples. Finally, it became part of modern culture. Museums, documentaries, and public exhibits keep the story alive, reminding humanity of our planet's fragile position in the cosmos. Summary: the Chelyabinsk meteor exploded over Russia on February 15, 2013, releasing hundreds of kilotons of energy. The largest fragment, weighing about 540 to 570 kilograms, was recovered from Lake Chelyabinsk on October 16, 2013. It is now displayed in the State History Museum of the Southern Urals in Chelyabinsk. The event captured global attention and remains a cornerstone in modern planetary defense research. A decade later, the lessons of Chelyabinsk continue to shape scientific understanding and humanity's preparations for the next cosmic visitor.